Hey guys, what's going on? Paul here. Welcome back to another Cardano video. Today is a little bit different. We're going to dive a bit deeper into how Cardano is built or why use something like the EUTXO model. So I'm joined by the CTO of Ardana, Isaac. Thanks very much for taking the time to come on here. Do you want to give an introduction to yourself?
Yeah, it's a pleasure to be on your program. My name is Isaac. I'm currently acting CTO of Project Ardana, interested in blockchain and Plutus smart contracts in general.
Great. Yeah, anyone who isn't actually familiar with Ardana, I've had Ryan on the channel before for an interview as well. So I'll leave links to that down below for anyone who wants to check that out. And we probably will get into a bit on Ardana in this call too. So I suppose you guys put out a really good research paper on the EUTXO model, which is what Cardano uses. So we'll kind of try and keep it fairly high level. I'll put the links down below as well for anyone who wants to really dig into the paper. But the EUTXO model, so with Ethereum, they use something called an account-based model. Cardano has gone with an EUTXO model, which is similar to Bitcoin, but different at the same stage. Do you want to kind of explain the EUTXO model, what it is first, and then kind of how it's different to an account-based model that Ethereum uses?
Sure, I'll do it kind of a little bit in the reverse though. So
Yep.
with Ethereum, the accounts-based model is basically mutable state in the blockchain. So it's very straightforward. If you have, you have an account, that account represents a particular amount of value. If you wish to transact, money is being, an asset's being deducted from account A and then added to account B, right? So this model yields a very straightforward method of programming in a lot of ways, a very imperative method of programming. That method also has some pretty serious weaknesses compared to a purely functional model, which is what Cardano has. If you have, and that model also implies rather high fees. For whatever reason, the accounts-based model is somewhat responsible for the high gas fees on the Ethereum blockchain. A UTXO model more closely models a real-world currency where we might have change, where we're going to do a transaction, and UTXO stands for unspent transaction output. Now, Bitcoin uses this model, and it's been a great model for Bitcoin. Bitcoin, however, doesn't have smart contracts. There are limitations to the simply having a UTXO if you want smart contracts. The EU UTXO model extends the UTXO model that we saw in Bitcoin with the ability to attach things like arbitrary data to a UTXO. So more or less, we have a circumstance where a UTXO represents unspent transaction output. So that might represent some ADA, right? And so a wallet may contain one or more UTXOs containing some ADA, for example. A UTXO can be consumed only once per block, and then we'll generate the creation of a new UTXO. So given this model, it's more purely functional, and as a result, we can get better security features, better correctness features in our smart contracts. There's a ton of benefits there. The downside is, as well as greater efficiency potential, the downside is that the EUTXO model for smart contracts is not something we've seen at scale in production yet. And so a lot of thinking has gone into, how do we write a DeFi app on an accounts-based model, and not the same amount of time has passed since we've had EUTXO smart contracts. And so as a result, there's a needed shift in design thinking there in order to support the idea that, it's not an account. It's a particular object that's going to get consumed once and then produce a new object. And so with this, we don't have immutability. A UTXO exists once and only once.
Really good explanation, I suppose, for some people as well, to bring it back to addresses. So Ethereum, you have one account, so that means you have one address. So that's why everything is in and out of the same address. With Bitcoin, with Cardano, you have one wallet, but you could have hundreds of addresses all linked to that. So similarly, you can have hundreds of EUTXOs or UTXOs. So you could have a few ADA sitting on 50 different addresses. So when you're trying to use that, you have to be able to access the individual UTXOs. So when you look to scale this up then, or as you say, developing for the first time, we're building as well on top of Haskell with Plutus, and there's lots of, I suppose you're going down lots of new territory as well. So when you're developing on top of this, how has it been?
It's been pretty good overall. It definitely requires different design thinking, especially given that things like the Hydra scaling solution is not yet up. So that means that, you know, block creation is a bottleneck. It's a limiting factor, right? So we can consume a UTXO. Consuming and creating a new UTXO requires a block. And so that means that throughput, if you were to write the smart contract the same way you would on Ethereum, is going to be 3 transactions per second, which is appropriate for certain types of smart contracts. It is not appropriate, for example, for high scale, right? If you have lots and lots and lots of transactions coming through, if you're only able to process 3 transactions per minute, you're not going to have happy customers, right? So we need to think about this a little bit differently. And it's not so much an obstacle as it's a different design conversation, right? So we've found, you know, numerous ways in which it's possible to scale with UTXOs on, you know, the current era of Cardano. You know, we've selected ones that we think are going to have the highest levels of transaction throughput for the future. But, you know, what strategy and what kind of design patterns you're going to use for EUTXOs is really project specific and dependent on what your design is and what your goals are, you know.
Anyone who hasn't seen the previous videos, you guys will have full money markets. I suppose you've lending and borrowing on top of Cardano. That's and right. You also have, a DEX. It's not the traditional DEX that people expect, like Uniswap on Ethereum or what some of the other DEXs are going for on Cardano. It's a stablecoin DEX, but you guys will, I would expect, have a lot of volume going through there, a lot of different transactions. So we did hear concurrency, this major issue for Cardano, but it's not something that stops DeFi. It's, as you say, it has to be done in a different way. You can't just fire everything into one block with the way the UTXO model works.
That's right. So, you know, I'm not going to say it's an issue. It's just a different way of thinking about it. So, you know, we have to think about it in these terms for the time being, where we can only consume a UTXO once, right? So if you have an accounts-based model, concurrency is a bit more straightforward. But like I said, there's a huge disadvantage to the accounts-based model in terms of the computational work required. You end up with very high fees to transact those types of things. With the UTXO model, you need to think about it differently. So for example, you know, there's sharding. You can do a sharding pattern where you can have many instances of a smart contract and a service that picks. You can also do something like a buffering pattern where all transactions take exactly 2 blocks. But that means that you are kind of buffering data in the datum of the UTXO, of the EUTXO, as part of that the E part there, that it's not just UTXO, it's the extended model out from that. So we can batch up transactions in one UTXO for that block. And then in the next block, have a single kind of giant UTXO that performs all those transactions in one go. And so in that way, you can have, you know, thousands of transactions occur in 2 block time instead of, you know, 1 block time.
Okay, yeah, that's interesting. I suppose as well, Cardano works in a 2-phase transaction process as well. It's not like on Ethereum when you make a transaction, your transaction could actually fail if you don't pay enough of gas. The transaction fails, but you still pay all the fees. Within Cardano, again, this for people watching who mightn't have heard this, the fee doesn't actually come into play until phase 2 then. So if your transaction fails, you don't actually pay the fee. Now, I know there's different conversations ongoing right now about should we look at fees and should fees give you priority in your transactions. And I think there's all types of scaling conversations ongoing at the minute. What's your own thoughts kind of on Cardano scaling or where we go? I know Hydra is the solution that's looking, I think Q1 was the beta, is when they're hoping to have beta out. But
That's right.
what do you think yourself?
Anything to do with scale is ultimately being addressed, right? It's addressable now through careful design decisions, and there'll be more options to address it once we have side chain, Hydra, these types of things. So I'm expecting, the Cardano model, at least in my opinion, is unambiguously superior to Ethereum's model here. We can have our cake and eat it too in Cardano. It's just going to take a little bit of time. We're on the absolute bleeding edge. Smart contracts just got support on Cardano. The PAB is about to get released so that we can do more things. And once those solutions are there, I expect transactions to be very fast and very fluid.
Okay, yeah, it's great to hear that. When you hear some of the other conversations ongoing, mainly I suppose people on the outside who doubt what Cardano can do. And right. To a degree, I can't blame people either. Like smart contracts came on September 12th, but we still haven't shown what smart contracts can actually do on Cardano. And to a degree, I suppose people don't fully know themselves, even developers, until we get another few months down the line, until we have all these extra tools, all scaling and everything like that comes into it. So in terms of Ardana, Ryan said when he was on the call, that's probably 2 months ago that I was talking to him then. So he had your different workaround or your different solutions for concurrency, how you were going to handle that. How has development been going for Ardana, or where are you now?
It's actually been going incredibly smooth. We've had a lot of uncertainty because of the newness of the technology, and also because, critical APIs that we need to be in production were not ready at the same time smart contracts went live. For example, wallet connector software was not ready, right? The PAB is not ready. So once these things are done, we were going to see DeFi apps show up on Cardano, and I think they're going to be highly capable. One of the challenges that I'm kind of seeing in the space in general is that there's a lot of entities that want to be a first mover in Cardano DeFi. These entities, we know that Cardano is going to be a better solution than Ethereum. There's a litany of reasons why we know Cardano is going to be a better solution than Ethereum, but we haven't seen it yet. And part of the challenge there is that people are taking ideas and code bases that were written for Ethereum and trying to implement them on Cardano. And going from an accounts model to an EUTXO model is not a mechanical process. It requires some degree of rethinking. And if you do it in the most straightforward possible way today, you're going to fail because you will not have the throughput you need. Now, granted, not all projects are the same, right? How much throughput you actually need is project dependent. And how large of a UTXO you're going to need. There's also a limit on the UTXO size today that I'm told is going to be increased. So today that limit is rather small. That limit's going to go up. And so as we see these kind of restrictions limited, these restrictions that are limiting lifted, and we see the critical APIs showing up for us to use, and they are, by the way. For example, the Emergo wallet just published their DApp connector, and so that API is now available. The PAB should be here, in my expectation, within about a week. So as these things show up, we'll have kind of more things being more concrete. But these were areas of uncertainty for our project, certainly. Without those APIs being there, we don't know how things are going to work just yet. We have to kind of code around it. But for the most part, it's actually been incredibly smooth. And things that we thought would be more challenging have almost universally turned out to be less challenging than expected. And that's a really wonderful thing. Another component there is that it is Haskell. I myself have been a Haskell developer for a number of years. Before I got interested in blockchain at all, I was doing Haskell. Haskell has amazing properties for things like writing algorithms in a highly verifiable way. We're doing some formal verification, so actual mathematical proofs, machine-checked proofs on code. And so the level of confidence that I feel like we can have in this code is just worlds higher than any level of confidence we can have in Solidity code today. So with that, we've been able to leverage that. And so that's been a way that we've been able to reduce uncertainty, as well as been pleasantly surprised by some things that, would be really difficult and error prone to implement in Solidity, that we've seen code there have problems. And on the Haskell side, we've had zero problems with some of those types of abstractions. And so that's really wonderful.
Okay. That's actually great to hear that you have a long history within Haskell as well. It's definitely a massive advantage coming into this. How have you found getting into Plutus then as well? Having the Haskell experience, how has the transition been with Plutus and with smart contracts for Cardano? And how have you found that?
So Plutus in general feels like it is very much an MVP at the moment. The way the Plutus compiler works is it branches off of Haskell core. So essentially what happens is GHC, which is the mainstream battle-tested Haskell compiler, the Glasgow Haskell compiler, takes the Plutus code and compiles it down to Haskell core language, which is a substrate language below Haskell, so it desugars to that. And then from there, the Plutus compiler takes over. And the Plutus compiler does not accept all Haskell code, right? So Haskell is like a superset of what Plutus will allow. And there are some things there that are a little bit unfortunate. For example, because of size limitations, we can't take full advantage of all the things Haskell has to give us in the type system and assurances today. But that's really because Plutus is kind of in an MVP state at the moment. Those types of functionality will show up and allow us to take advantage of more of what Haskell has to offer in Cardano smart contracts. But today it's a little bit limited, and just because it is so new, there's some rough edges that we've had to deal with that have been a little bit unfortunate. But for the most part, it's been fairly smooth. Certain APIs we found are not appropriate. For example, like the state pattern, state machine APIs, these things are not ready, so those have to become validators. That's not the best, that's not ideal, but it's also not like a huge obstacle. It's just that, we're really at the cutting edge of something. And this ecosystem is at its starting point. Ethereum's been around for a while. It's gotten pretty mature on some of these issues. And Cardano, it is where it is right now. Yeah,
I suppose people forget as well that Ethereum didn't overnight turn into this, I was going to say brilliant system to write smart contracts. It's still not brilliant to write smart contracts. There's lots of areas for security flaws, and even some that aren't just flaws, that where people are able to put backdoors and different things like that in that slip through.
That's right.
So things don't just happen overnight. And on Plutus as well, I think, is it Babbage is what they're working on now, which is optimizing Plutus. Like they put out version 1, but now I think I heard it called Babbage or something like that will be the hard fork that will bring the improvements. I'm not sure of the time frame on that either, but something like that will unlock more utility or make it easier anyway for developers.
I think both. In my opinion, Solidity is not an appropriate language for smart contract development because these are things where there can be millions of dollars flowing through this piece of code. Yeah. You really want to be sure that that code is right, that it's correct, and not only that it's correct, but that the protocol is correct. You can have protocol level bugs where unintended consequences to the protocol can cause major problems for your project. Verifying these types of things in a language like Solidity is really challenging. It also means that because of the nature of that language, the barrier to entry is pretty low, right? So you end up with junior developers, these types of folks, putting out projects in Solidity that don't have the proper level of security, the proper level of vetting, the proper level of auditing, proper level of verification, proper testing protocols in place, good engineering practices, all of this stuff. And then you see iteration, right? And so eventually, some of those projects end up getting battle tested, and it's kind of proof of correctness through execution, right? Which means that you using the contract is how we end up determining that that contract works as expected, right? With a language like Haskell, we can do a lot of that up front. And so in some ways, you can say that slows down development, but ultimately, I think it's better for the users and it makes Cardano projects more credible in general. the barrier to entry for Haskell is very high. A lot of the people, that are working with me right now on Plutus, some of them are, math PhDs, ex-academics, principal level engineers. These types of folks show up in the Haskell space organically because it self-selects for this type of mentality where we really need to have a high bar in terms of the code quality. Solidity has the opposite characteristic there.
Okay. Yeah. Haskell developers are, from talking to different projects, to get experienced guys in Haskell right now it's very, very hard to do. So what you're saying there with the PhDs and stuff in your team, that's something that really stood out to me from Ardana as well, was the team that you guys had, the actual, just the varying degrees of experience and different people skill sets that you seem to have on the team was something I really liked. It seemed to be a good balance of that, of what a project actually needs. So
yeah,
you mentioned on security as well and verifying codes, audits. Have you started the process, or have you looked into that yet? It's another thing I've heard, that getting
absolutely
trusted companies to audit the code, because I don't want to use a money market that hasn't been proper audited and stuff like that. You see too many hacks and different things ongoing. So it's definitely something I suppose in the Cardano space, we're used to everything being tested and verified and all that. So how have you found that, or have you gone that path yet?
So I have a tremendous amount of confidence in the team at Ardana. It's the best team I've worked with personally. And we've implemented, pretty stringent testing protocols across the board, comprehensive domain level property tests, which are kind of poor man's mathematical proof. But the one advantage that those have is that we can do things like write tests against real world integrations. So for example, we have an off-chain component. We're able to write property tests against the database, which basically future-proofs us against even the potential of failure in one of those database calls. These types of things give me a really high degree of confidence. As far as the auditing goes, we're currently midway through the first phase of auditing. The first phase of auditing that we're doing is a spec level audit by a logician. His name is Quinn Doherty, who's going through and verifying that. I also have the participation of Bassam Awad on this, who's an economist, PhD from the University of Florida, who's looking at the specifications and protocols of the system to try to make sure that it's trustworthy from that level. I view that as actually the most important level to do here, because the testing that we have is so robust. We are working on formal verification as well, which I would consider to be part of the auditing process, where we will have computer-checked mathematic proofs of critical parts of the code. We should have some of that done before launch, but that effort is going to be continuing after launch as well.
As the Plutus side is evolving all the time as well, that testing, auditing is going to be a continuous basis. And as you guys bring out, I presume you're not going to have everything in the protocol on day one. That's going to be building all the time as well. So continuous testing and auditing is going to be an ongoing in the space, I suppose, anyway.
It's going to be ongoing in the space. It's definitely an ongoing effort. We're in blockchain. And with blockchain, there's not insurance. You don't have FDIC. You don't have these types of assurances. So really, we're putting our trust in math. So the replacement for having, a centralized trusted entity like a government or an organization that, can be sued, we're putting our trust in mathematics. And I feel that mathematics is highly trustworthy. But the process of formally verifying and auditing this is not simple, and it's not easy. It's a lot of work.
And does Haskell bring in advantages there, or disadvantages? I presume they bring in some advantages from being around so long. Unlike, I suppose, Solidity, Haskell has been there, it's been proven. Are you able to use some of the test cases and everything from down through the years of Haskell?
Absolutely. So, Haskell's major benefit is, that it is an advanced, purely functional programming language. So the code there is fundamentally pure. And by being pure, it means that it is equational in nature, which means that we can far more trivially verify Haskell code. Theorem provers typically already have connectors to the Haskell language, because Haskell is really the battle-tested industrial version of this style of programming. So, for example, IOHK or IOG, depending on how you want to say it at the moment, has formally verified huge parts of the Cardano blockchain itself. Like, the consensus algorithm, Ouroboros, has been formally verified. Because we have an actual mathematical proof that really proves that, it's peer reviewed, that this algorithm has the properties it says that it has. That would be far more difficult in an imperative programming language. The choice of Haskell here, in my mind, is really golden.
Okay.
And like I'm talking about these property tests, which I described as like a poor man's mathematical proof. It's a machine check test. IOG's validators, right? IOG's DApp system this way to get approved is actually just a suite of property tests. So something like that would just not be possible in another system.
Okay. Yeah, because you hear other people saying the disadvantages of Haskell. Well, it's great to hear from someone who's been working in it, hear real experience of it, rather than people's opinion of what it might be. Or there's lots of that out there. There's lots of opinion, but I always like to hear from people who have experience in that sector.
I really want to make a crystal clear distinction between immaturity and quality, right? Between maturity and quality. What we have right now in Plutus is immaturity, not a deficit of quality, right? Those are very, very different things. So when the PAB is released, I'm expecting a high quality product, right? An immature, but high quality. And quality is really what's important here. Things will mature, but it's really difficult to take something that's low quality and make it high quality. It's much more straightforward to take something that's high quality and immature and extend it and mature it and grow it, right? Additionally, something that's high quality but immature is going to be extensible and able to grow and iterate much faster. Something that is mature but low quality. And so this, in my mind, is like the critical distinction between something like Cardano and Ethereum. Ethereum came out as low quality and immature and matured, but it never achieved high quality, which is why we see these types of problems, why we're seeing so much interest in people moving from Ethereum to Cardano. Cardano right now is in the opposite space. Things are very, very high quality, but immature. And that just means time needs to pass. And once that time passes, we're going to have something that's absolutely brilliant.
Okay, yeah, I suppose Ethereum, they move fast and break things and try and fix them along the way, which sometimes things go too far. And when that was probably okay when we started out first with smart contracts and stuff like that a few years ago. But now when you look at the volumes of money that's involved in this and the stakes that we're at now, it's just not to me anyway, it's not something that you can just put out to chance. That look, we'll throw it out there and see if it works. And if it does, brilliant. If not, we'll try and fix it. We're gone past that stage of development for where blockchain is and where smart contracts, money markets, everything like that is. It needs to slow down, verify first. Maybe people will say Cardano's slow. We will all admit they are slow in what they're doing, development. But if they're producing the quality products at the end of it, then that's what counts in the long term. Because a lot of what Cardano does is long term. It's not.
That's right.
It's not short term. It's not trying to pump the markets based on we're releasing this and it's going to do this and that. Their focus is very long term.
Well, like I'm saying, it's blockchain. We have to put our trust in the contract. That means we need to put our trust in math. And I'm not trying to dunk on Ethereum, just to be totally clear. I'm a big believer in Cardano, and that comes across. But I'm not trying to dunk on Ethereum. Without Ethereum, we wouldn't have a Cardano, right? That was a necessary stage in the development of blockchain for real world use and for, to really replace the current financial system. And it was a necessary stage of development. But long term, if we're going to replace the global financial system with blockchain, we really need something that we can have an extreme degree of confidence in. And in my mind, that means equational code, formal verification, and peer review. And that just takes time. It does. There's no way around that.
Yeah, and I'm definitely not putting Ethereum down either. People give out to me at times because I give so much credit to Ethereum and what they've done. And I don't think there is an Ethereum killer out there. I think Ethereum is not going anywhere. I think that the market share for smart contracts, for what smart contracts and everything can be used for going into the future is only going to explode in what's out there. And I think the likes of Cardano is going to have a massive share of that. I think Solana will be there. All these other blockchains that are out there, they're not going to disappear. They're all going to have different types of niches, and they'll just have different percentages of the market. There's no one, it's no one wins and everyone else loses. That's not how the world works.
I don't think one's going to win and everyone else is going to lose. Certainly, I think we're going to have a lot of blockchains going forward, but this is part of the natural cycle of technology. When you have something really innovative like blockchain, you're going to see a large proliferation, a lot of experimentation, a lot of fragmentation, and then that market cools down, and there does usually arise a natural winner in that space who ends up being dominant for a while. That dominance lasts for a period of time, and then eventually, that dominance fades, largely because once you get to a certain level of scale, you can't iterate as quickly because so much depends on it. At which point we should see, more creative explosion happening again. And this is just kind of a cycle that we observe in technology in general. So it's an exciting time to be in blockchain right now because of the stage of the cycle we're in.
Yeah, definitely is. And there's so much to come over the next few years as well. Even in the last year, if we look at the space, some of the advancements that's happened in the space, not just in Cardano, and the space in general, there's so much has happened, and it's only going to get faster. How much innovation is out there, and new types of markets, new ways of doing things as well.
Well, and for that matter, circling back to the EUTXO question, it's a different design pattern. It's a different design context to be working in this, very verifiable, purely functional context, right? And right now, a lot of what's happening is taking ideas that we know work from Ethereum and using those ideas in Cardano smart contracts. I expect there to be new ideas that we haven't seen yet emerging in the next few years that require UTXOs, that maybe don't work on an accounts-based model, because the EUTXO model has some wonderful properties, like I mentioned before. So the space of creativity here, we haven't even really seen it yet. We're seeing, a lot of movement of things we know work. And that's great, because we need those projects. We need those high credibility projects, I would say, like Cardano, on Cardano, to kind of show, hey, DeFi on Cardano is really a good thing, but we're going to see creativity here too. And for that matter, one of the disadvantages, if you want to state it that way or frame it that way, for Haskell is that it does have this very high barrier to entry, right? You have to gain an understanding of a whole bunch of abstract algebra concepts like functor and applicative and monad and these types of things in order to just get started working, right? So that high barrier to entry is one business model, There's not necessarily something wrong with not having that barrier to entry, right? Junior devs doing things. Junior devs are creative folks, it's not like all the creative smart people are Haskell engineers. That's not something that is a true, that wouldn't be a true statement. So we're going to need things like Ethereum. We're going to need these other things long-term, in part as testing and proving grounds of new ideas that are kind of coming out of people who maybe don't have the technical or mathematical acumen to be writing Plutus contracts. As part of what makes me happy about hearing about, the KVM integration. We'll have some Solidity support on Cardano as well, and that should hopefully kind of ease the wall between the two a little bit.
Yeah, it's definitely have the creativity from all over. Like, I can't remember the company now that's building that will allow most programming languages to be able to build on top of Cardano as well, that you won't have to always have Haskell experience to do that. Maybe there will be certain functions and stuff like that teams will prefer to use Haskell for it, but the doors will open. It's not there yet. It will be Haskell developers that are putting out all the first applications on top of Cardano. Maybe this time next year, it will be a lot wider for other programming languages to be able to be used then.
Absolutely. And, you know, long term as well, I do think Haskell is going to have a long-term home, you know, with Plutus contracts, just because, you know, when you endeavor to support a non-native programming language on a platform, it's going to have some problems in terms of accessibility of low-level APIs and being able to do things in very highly granular ways, right?
Yeah.
To support Solidity there means that you're not going to get full support for everything Haskell is going to have. The Cardano blockchain is written in Haskell, and Haskell is going to be his first-class citizen. So, you know, this should be a wonderful thing as well, because, you know, you could have another programming language. People wrote something that, you know, constitutes as a really good quality prototype, and then we can actually bring that up to a very, very high level of esteem through Haskell, where doing that on another blockchain would be next to impossible.
Yeah. Yeah. So I think there's lots of talk as well about the different projects that might move to Cardano and moving different smart contracts. And I'm not sure that's always going to flow directly across, like something smart contracts that work really well on Ethereum, then just porting that across, even if there is the EVM or whatever to let them run on Cardano, maybe they don't run as well as they should. They need to relook at how they can be rebuilt on top of Cardano in a better way, in a more secure way in the long term. Right. Maybe to start, it will work with the converters and everything that's there, but individual projects, to be individual advantages, disadvantages to doing it each way.
That's right. I expect it to work to a large degree, but I don't expect it to have 100% the same properties as writing your smart contract in Plutus directly.
Yeah. A lot of people ask me, like, oh, what projects are going to come in and what's going to move across? And I'm not that bothered about the ones that will move across. I'm more looking to, right, like Cardano, other projects that are out there as well, what's building natively on Cardano. And we don't have to have the other projects moving across. There will be some, and there will be some big names will move, but to me, it's what are being built natively within Haskell, within Plutus, from the ground up here. They're the ones that I think long-term are going to be the most solid. That's probably a good point to leave it at. I really enjoyed this, getting to talk about it. I've learned a lot in it. I hope everyone watching has as well. I'll definitely have Ryan on closer to the launch, maybe at some stage when things are up and running as well. I'd love to have yourself back on for more on the tech side too, on what you see Ardana, how development is, how Cardano is evolving as well with all the future updates that are coming as well. So thanks very much for your time. I really do appreciate it. I will be linking off to the research paper you put together as well, which was done by your company as well, I think. So I'll have all them links down below.
Anyone done by Morgan Thomas. Morgan Thomas is a brilliant engineer and brilliant mathematician, and I can't speak highly enough about him. The work he did on that was pretty incredible. Most projects and most companies are not publishing their EUTXO design patterns and kind of keeping that secret. They're saying that they have such a pattern but aren't talking about what it is. I took the opposite approach and said, we're going to publish everything we know. And so we did. And I hope that gives people a bit more confidence in our capabilities.
Yeah, it's great to see. And look, blockchain, so much of it is open source. So it's great to see what you have is a competitive advantage to you if you keep it to yourself, but it's great to see that it's been shared out there as well to hopefully spur ideas within other projects too. So all them links will be below. Anyone who is new, please do share this out there. Put the information out if you think it can help others. Leave your own thoughts down below as well. I will try and come back. If I can't answer them, if they're too technical, I will pass them on to the team as well. And don't forget to subscribe for future videos. Thanks again, Isaac, and I will talk to everybody soon.
Thank you very much. It's been a pleasure. Thank you so much, Paul.
Thank
Cheers.
you.